Assalamualaikum warahmatullahi wabarakatuh. Hi 11 graders, hope this video finds you well and welcome to the second semester of this academic year. Wow. Okay, for this semester we have some interesting topic in physics and one of them is superposition. Okay, I guess that this is something new for you. Okay, and in this topic we have three subtopics which are standing wave, diffraction, and interference. Okay, and yeah, the subtopic is similar, not similar. I mean, the subtopic it seems that new also for you. Yeah. Okay. Before we start discuss about the standing wave, let me explain how we classify waves so you can understand what the definition of standing waves. Yeah, standing wave, we can also mention this wave as stationary waves. Okay, for classifying waves, we have three ways. First, we can classify waves based on the medium. Based on the medium, we have two waves. They are mechanical waves and electromagnetic waves. I believe that you already understand of these two waves and can give me some example. Okay, and then the second way to classify waves, we can classify waves based on the direction. Based on the direction, we have longitudinal waves and transverse waves. Correct. Yeah, I also believe that you can give me some example because these two waves is very familiar for us. Now, the last one here, we can also classify waves based on the amplitude. Based on the amplitude, we have also two waves. They are progressive waves and standing waves. Now, for progressive wave, actually we already discussed in the last semester. Yeah, in progressive wave, we can see the crest and the trough can travel from one place to another place. So the energy transfer can be easily observed. But in this standing wave or stationary wave, as the name implies, stationary, that means doesn't move. So yeah, the wave seems to not move to any other location. So we can just observe that the wave just oscillate up and down, not traveling. Okay, if you are interested in this topic, please keep watching and let's start this video by saying basmalah. Bismillahirrahmanirrahim. Okay, everyone, now I already opened a simulation from Faith. Here, I would like to show you how stationary or standing waves can produce. Okay, before I demonstrate the standing or stationary wave, here I have to set this simulation. First, I choose this one, pulse. Okay, and then I set the damping to none. That means the kinetic energy will never lose in this simulation. And then for the tension, I choose or I set low. Okay, and then for the amplitude here is 0.75 centimeter and the pulse width is 0.5 second. Okay, when I press this green button, so I will have a pulse that come to the fixed end and it will reflect, but the direction is the opposite. Yeah. Okay, and then reflect again. Yeah. Now, because at the end it's fixed end. Yeah. So the pulse reflect and the direction change. Okay, now to see how the stationary waves produce, I will give one more pulse. And then, okay, let's see. Here is it. Okay, see here we have two. Yeah, you see, yeah. We have two waves now. And when they meet, they oscillate, they result a new wave that has higher amplitude. Okay, you see again. Nah, What if I add more webs here or pulls? Okay, let's wait until this pulls pays. Okay, I add more. Okay, you see? Yeah, it seems like when the two webs meet at a point, so it seems that a particle at that point, yeah, doesn't move. Okay, here, yeah, you just see. Now, so that's basically the principle of superposition. Yeah, when we have two or more webs meet at a point, so the amplitude will add or subtract each other. Sometimes it will produce new webs that has higher amplitude, but sometimes it produce new webs that produce new web that has lower amplitude. Even moreover, produce or the web cancel out each other. Okay. Now, uh, now, okay. What if it's not pulse but a wave? Yeah. So here I choose oscillate. So it will produce waves uh, time by time, and it will make in stationary waves. Okay, here. Okay, please see the moment when this stationary wave produce. Okay, you see, yeah, basically this point already combination, yeah, between the initial waves and the reflection waves. Okay, you see, there is a point that it seems doesn't move, like this green particle, yeah, it feels like it doesn't move, but basically, we have two waves at the point. One wave that travel to the right and another wave travel to the left. Okay. Now, so that's why this wave we call it a standing or stationary waves, because here we have a particle that it seems doesn't move while other move or oscillate. Okay, let me restart. Okay, it's already okay. And then I will slowing down, yeah, to make it easier in observing this web. Okay, you see, this is the initial web coming to the fixed end, and it will reflect. Okay, and then the reflection makes superposition with the initial one. And then you see, it feels like this green particle doesn't move. Yeah, only this one. Basically, they are moved. They consist of two webs. So that's why we call it as stationary webs, because here we have this particle that it seems doesn't move. Now, this part of the stationary webs, we call it as nodes. That's mean a point of the web that seems doesn't move. And the opposite, we have antinodes. Yeah, in this simulation is this point. Yeah, antinode is a part of the web that oscillate up and down. Okay, let me restart again because the amplitude is already too long. Okay, let me pause first. Okay, this is the initial webs. We know that this is transverse wave initially, and to measure for one wavelength, it should consist of one crest and one trough. Okay, so the wavelength we can measure from this point until this point. Okay, now so if it's already a stationary or standing wave, one wave should consist of, yeah, basically the same. It should be one trough and one crest, but now, okay, let's wait until it's produced the stationary waves. Okay, we got it. Okay, let me pause. Yeah, here it's already make a stationary webs in this site. So basically the same, yeah. From what is it now? This green ball is the node, and until the next node is one wave. Yeah, so the distance between these two nodes is one wave. Or we can also measure the wavelength from antinode to the adjacent antinode. Okay, let me start again this simulation. Okay, you see, yeah, this green particle doesn't move while others moving. Nah, okay, understand everyone? Okay, yeah, that's all, yeah, for this session. Yeah, I just would like to show you how what is it, standing or stationary webs produce. Okay, hopefully you understand. Okay, that's all for today's discussion. Before we close this video, let's summarize today's topic. We just discussed about standing webs. Okay, now you know what's the difference between standing webs with other webs. In standing webs, here we have nodes and antinodes. Okay, can you explain what is node and antinodes? Can you? Okay, correct. Yeah, node is a part of the web that doesn't move, while antinode is a part of the web that's oscillate up and down, like that. Okay, this just a little review for this topic. You can explain. I mean, you can explore more about this topic by reading the material that I already provide in this learning management system or BAS. Okay, I think that's all for today, and thank you for watching everyone. See you again in the next video. Let's close this session by saying Alhamdulillahirobbil alamin. Wassalamualaikum warahmatullahi wabarakatuh. Bye everyone.